Dear students, today I am going to take up module 3 energy systems. Now module 3 energy systems, under these energy systems there are 3 subheadings. One is chemical fuels. Chemical fuels, you are going to study it in details about chemical fuels. Then is fuel cells, and solar energy. Now under this model 3 in the energy systems, you are going to study it in details about chemical fuels, fuel cells and solar energy. Now in the chemical fuels, the chemical substances undergo combustion, it gives heat energy. Heat energy is converted into electrical energy. And the fuel cells, in this chapter we are going to study chemical fuels, the classifications, definition of calorific value, then how can you determine the calorific value of the solid or liquid fuel by using bomb calorimeter, and then knocking and its mechanism, ill effects, and then prevention of knocking, biodiesel, power alcohol, these things you are going to study in these chemical fuels. But in the fuel cells, the batteries, the modern batteries are the fuel cells. By continuous supply of fuels to the batteries, you can easily to get the energy. That is, a conversion is different in these 3 cases, but in the solar energy, this a direct electrical energy is generated when light radiations are illuminated on the surface of PV cells, photovoltaic cells. Now I am going to take up first chemical fuels. I think all of you know that first law of thermodynamics. What it says? In the universe, the energy is constant. The energy in the universe is constant, neither be created nor be destroyed, but it can be changed one form to other form. The same thing here, the chemical fuels is the different form, heat energy is converted into electrical energy. Here chemical energy is converted into electrical energy. In this case, direct electricity is generated. Now I will take up these chemical fuels first. Now what is the introduction about the fuels? Now the energy is an important aspect for human activities. To do any work, you have to spend for some amount of energy. Now what are the energy sources? The large amount of energy sources are available. The energy sources are, one is that is firewood, even animal waste, coal, oil, that is a natural oil, that is an crude oil, coal, oil and natural gas. Even sun, solar energy source, sun, even wind energy, etc. Now these are the sources of energies, out of which coal, oil and natural gas, they call it as fossil fuels. Now unfortunately, the fossil fuels supply the energy demand in the world is about 80 to 85% of energy demand supplied by these fossil fuels. The remaining what other sources are available, that is about only 10 to 15% of energy demand is supplied by these other sources. Still we are dependent on fossil fuels, but fossil fuels are renewable energy sources or non-renewable energy sources. Now these sources can be classified generally into 2 types. One is renewable energy sources, these are non-renewable energy sources. All fossil fuels are non-renewable energy sources. Now coal, oil, natural gas, these are the non-renewable energy sources. This firewood, animal waste, these are all renewable energy sources. But in this chemical fuels, you are going to study in details about these fossil fuels. Now that is about the introduction about the chemical fuels, but what is meant by fuel now? Then you come to that fuels. What is that fuels? What is the definition of fuel? Fuel containing what is the chemical constituent? What happens when undergo combustion? Now fuel can be defined as it is a combustible substance. It undergo combustion in presence of oxygen. Now fuel is a combustible substance. It undergo combustion in presence of oxygen or air. Combustion without oxygen is not possible. Combustion is always takes place in presence of oxygen or air. The fuel undergo combustion that can be defined as, fuel can be defined as it is a combustible substance. It undergo combustion in presence of oxygen and it gives combustible products. Combustible products plus what? Combustible products plus energy. Energy in the form of either may be heat, light or power. Heat, light or power. Now energy is produced in the form of heat or light or power. Now that is the definition of fuel. Fuel can be defined as it is a combustible substance. It undergo combustion in presence of oxygen and it gives the combustible product plus energy in the form of heat, light or power. That is the definition of fuels. Then either may be solid fuel or may be liquid fuel or may be gaseous fuels, but all fuels containing what chemical constituents? The chemical constituents present in the fuel is hydrogen and carbon. Hydrocarbons present in the fuels. Hydrocarbons present in the fuel that will undergo combustion in presence of oxygen. Now hydrocarbons, it react with oxygen that gives combustible product. What is the combustible product you can expect? Hydrogen react with oxygen, it may produce water in the form of steam. Now carbon react with oxygen, it gives either may be carbon monoxide or may be carbon dioxide plus water is produced in the form of steam. Water is produced in the form of steam during combustion process plus energy. Now energy is produced. Okay. Now these are the products, combustible products are produced during combustion process. But the fuel containing only hydrocarbons is well and good. Now these oil, crude oil containing small amount of, in addition to hydrogen and carbon, this containing small amount of sulfur and nitrogen. If any fuel, either may be solid or liquid or gaseous, if containing hydrogen and carbon is well and good, we expect only there are two combustible products. These are the pollutants, carbon monoxide and carbon dioxide is possible during combustion process. But in addition to hydrocarbons, suppose very little bit amount of substance like sulfur and nitrogen is present in the fuel, what are the products you are expected? Now if containing sulfur and nitrogen even with small amount, the crude oil containing 0.1 to 0.5% of sulfur, 0.1 to 0.5% of sulfur and 0.1% of almost nitrogen. Okay. Now this undergo combustion in presence of oxygen that will gives so many products, so many combustible products are produced, they are harmful to the environment. Now sulfur react with oxygen, it may gives sulfur dioxide or trioxide, SOX, X indicates number. Now sulfur dioxide or trioxide it gives. Then nitrogen react with the oxygen, it may produce nitrogen dioxide or trioxide, NOx. Then hydrogen, sulfur and oxygen, it may produce as sulfuric acid, that is an acid rain, H2SO4 it may produce. Then hydrogen, nitrogen and oxygen, it reaction takes place, it may produce nitric acid, HNO3. Now these are the so many pollutants are produced, even little bit amount of sulfur and nitrogen present in the fuel during combustion process. Then what you can expect, carbon react with oxygen, it gives carbon dioxide, and carbon react with oxygen, it may gives another product, carbon monoxide, carbon dioxide or maybe carbon monoxide. Then water, hydrogen react with oxygen, it produce water in the form of steam plus energy, energy either in the form of heat, light or power. Now these are the products are produced during combustion process. If any fuel containing only hydrocarbons, well and good, we expect only there are two pollutants during combustion process. But it contains very little bit quantity of sulfur and nitrogen, we may expect there are two products, 4, 5, 6, 7, 8 pollutants are produced during combustion. Therefore, the crude oil after extraction from the earth crust, that should be before subjected to fractionation, the sulfur content and nitrogen content should be removed by some other process, and then only they are subject to fractionation, and then you get the petrol, kerosene, diesel, etc. Now these are the fuels are produced during combustion process, these are the products. Okay. Now that is about fuel. What is the definition of fuel now? Fuel is a combustible substance, it undergoes combustion in presence of oxygen, it gives combustible products plus heat energy is liberated either in the form of heat or light or power. That is about the fuels. Then you come to the classifications. Classifications of fuels. Now in general we are classified renewable energy sources, non-renewable energy sources, but further classified on the basis of their occurrence. On the basis of their occurrence, the fuels are classified into two types. One is primary fuels, secondary fuels. On the basis of their occurrence, primary fuels and secondary fuels. Okay. Now primary fuels and secondary fuels on the basis of their occurrence. These primary and secondary fuels are further classified into three categories on the basis of their physical state, on the basis of their physical state. On the basis of their physical state, they are classified into solid, liquid and gaseous or gas. On the basis of their physical state, the fuels generally classified into three types: solid, liquid and gaseous. But in the basis of occurrence, primary and secondary fuels. Now the fuels can be classified into different ways. On the basis of occurrence, two types; on the basis of their physical state, solid, liquid and gaseous. Now we come to the examples. What are the primary solid fuel? What is the primary liquid fuel and primary gaseous fuels? Now all secondary fuels are obtained by the help of primary fuels. By using primary fuels, you can easily to derive the secondary fuels in the same physical state. Solid primary fuels, it gives secondary solid fuels. Primary liquid fuels, it gives secondary liquid fuels, like that. Now see the examples. Now solid primary fuels and the naturally available solid fuels, that is an wood, firewood. Then coal or lignite, coal or lignite. Lignite is a brown color coal, black color call it as coal, brown color named as lignite, that is all. Wood, coal or lignite, that is solid primary fuels. Then same way the primary liquid fuels are crude oil or petroleum. Crude oil or petroleum, that is a liquid fuel, is naturally available. The gaseous fuels are natural gas. Natural gas, it is available in the well of oils, oil well, the upper layer containing natural gas. Now, these are the naturally available solid primary fuel, liquid primary fuel, gaseous primary fuel. But by the help of primer fuels, you can easy to derive the secondary fuels with the same physical state. Wood, after burning, it gives, what it gives? Wood gives charcoal, and coal or lignite, it gives coke. That is in the solid state. Secondary solid examples, fuels examples, charcoal or coke. Wood gives charcoal, coal or lignite gives coke. Then crude oil, after extracted from the earth crust, they are subjected to fractionation. You get again liquid fuels. Now, liquid fuels like petrol, kerosene, diesel, lubricants, etc. Now, these are all the secondary liquid fuels. By the help of crude oil, you can derive petrol, kerosene, diesel and lubricants. Then natural gas, it produces coal gas, oil gas, even producer gas, okay, biogas, water gas, etc. Okay. Now, these are the gaseous fuels are obtained by the help of natural gas. By the help of natural gas, you can derive that coal gas, oil gas, producer gas, biogas and water gas. These are the complete classifications of fuels. On the basis of occurrence, primary and secondary fuels. The primary and secondary fuels are further classified into three categories on the basis of their physical state. That is a complete structure of the solid, liquid and gaseous fuels examples. Okay. Now, that is about classifications of fuels, definition of fuel and classification of fuels. Then I go for calorific value. Now, calorific value can be defined as the total amount of heat energy liberated when 1 unit quantity of fuel is completely burnt in excess of air. That gives the calorific value, 1 calorific value. Now, good example of equation, chemical equation is, you take that fuel, they undergo combustion in presence of oxygen, it gives combustible products plus energy in the form of heat, light or power. Now, fuel containing in general hydrogen and carbon. These hydrogen and carbon undergo combustion in presence of oxygen or air. Now, combustible products either may be carbon monoxide or may be carbon dioxide or water in the form of steam plus energy. That is the chemical reaction. To understand that calorific value, this equation is more important. They can easy to understand that. The calorific value can be defined as the total amount of heat energy liberated when it liberated 1 unit quantity of fuel. 1 unit quantity of fuel is completely burnt in excess of air, then equal to calorific value. The total amount of heat energy liberated when 1 unit quantity of fuel is completely burnt in excess of air, that is equal to calorific value. Suppose if you burn 1 gram of carbon, it gives 8137 calorie of energy. 8137 calorie of energy is released if you burn it 1 gram of carbon content fuel. Suppose if you burn 1 gram of hydrogen, it gives 537 calorie of energy plus 9 gram of water is produced in the form of steam. 9 gram of water is produced in the form of steam during combustion process. 1 gram of hydrogen present in your fuel, that will give this much of energy is released during combustion, and this much of water is produced in the form of steam. Same way, if contain that carbon content the fuel, if you burn 1 gram of carbon, it gives 8137 calorie of energy during this process. Now, calorific value, they are further classified into two types. One is gross calorific value. Then calorific value can be defined as, there are two types. One is gross calorific value, the further classification. Classifications of calorific value. One is gross calorific value, gross calorific value, or high calorific value, high calorific value. And second one, net calorific value or lower calorific value. Gross or high calorific value, net or lower calorific value. Now, but reaction is same. That all fuels undergo combustion in presence of oxygen. It gives these are the products and some amount of energy. But when is possible to get the high calorific value and when you get the low calorific value, you have to understand that. The same equation is enough to understand both gross and high calorific value or net or low calorific value. In some numerical problems, it may ask calculate GCV and NCV of the following data, or maybe HCV and LCV of the following data. What is that? That is a short form. GCV means gross calorific value, or it may call it as high calorific value. Don't confuse that. Net calorific value, it may short form is NCV, or it may be LCV, low calorific value. Gross calorific value or high calorific. Gross means high calorific value. Net means low calorific value. When is possible to get the high calorific value during this process, and when is possible to get the low calorific value? Now, we can see that the definition of gross or high calorific value can be defined as the same way. The total amount of heat energy liberated when 1 unit quantity of fuel is completely burnt in excess of oxygen or air, and the combustible products are cooled to room temperature. The combustible products are cooled to room temperature, you get gross calorific value. The same definition for net calorific value, the total amount of heat energy liberated when 1 unit quantity of fuel is completely burnt in excess of air, and the combustible products are not cooled to room temperature, not cooled to room temperature. If we cool it, they get gross calorific value. If not cooled, they become low calorific value. How? How is possible? When you cool that products, how is possible to get the high calorific value? Now we can see that reaction. The fuels containing hydrogen and carbon content, they undergo combustion in presence of oxygen. It gives carbon monoxide or maybe carbon dioxide plus water in the form of steam. During combustion process, water is also produced in the form of steam. Steam also having some amount of energy. Even in the earlier days, they run the train by using steam energy system. Okay, steam energy is also having some amount of energy. Steam energy, if you cool to room temperature the product, steam energy is added to the actual energy. Actual energy plus steam energy, then automatically it become high calorific value. That is the difference. If you are not cool to room temperature that product, the steam energy were not utilized, just expels out, then automatically it become low calorific value. You are used only the actual energy liberated by the fuel, you are not utilized the steam energy. If you utilize the steam energy, then it become high calorific value. Steam energy plus actual energy liberated by the fuel. If you are not cooled to room temperature, this simply expels out that steam energy, then you loss of steam energy, then finally it become net calorific value. That is the differences between gross calorific value and net calorific value. What is the definition again? Gross or high calorific value can be defined as the total amount of heat energy liberated when 1 unit quantity of fuel is completely burnt in excess of air and the combustible products are cooled to room temperature, then it become high calorific value. The same definition, just you can instead of cooled, you just added not cooled. The total amount of heat energy liberated when 1 unit quantity of fuel is completely burnt in excess of air and the combustible products are not cooled to room temperature, then it become net or lower calorific value. The lower calorific value can easily calculated by using mathematical equation. What is that mathematical equation? Net calorific value NCV can be easily calculated by using this equation. The gross calorific value GCV minus latent heat of steam, latent heat of steam. Now you can subtract the steam energy with gross calorific value, then automatically it become net calorific value. How can you calculate latent heat of steam? That is the standard equation is GCV minus 9 into 587, because 1 gram of hydrogen content produces 587 calorie of energy, that is a calorie into joules conversion factor is 4.187. Okay, 9 into 587 into this into percentage of hydrogen, depends on how much of hydrogen content present in that, divided by 100, divided by 100. Now we can write 9 by 100, you can write it as 0.09. 0.09 into 587 into 4.187, that into multiplied with percentage of hydrogen, that will gives the net calorific value. That is the equation GCV minus 0.09 into percentage of hydrogen, okay, that multiply with 587 calorie of energy released by the 1 gram of hydrogen content, that multiply with 4.187, that is a kilojoules per kg. That is the mathematical equation to calculate net calorific value, GCV minus latent heat of steam. Latent heat of steam can be calculated like this. 9 by 100 it become 0.09. How? 1 gram of hydrogen they are able to produce 9 gram of water during combustion process, that is a 9 divided by 100 percentage, then it become 0.09. Not 9 into percentage of hydrogen, 587 into 4.187, that is the mathematical equation to calculate net calorific value or low calorific value. Now that is about the energy systems. The energy systems, there are 3 subheadings: chemical fuels, fuel cells, solar energy. Under chemical fuels, definition of chemical fuel, classifications of fuel on the basis of occurrence, on the basis of their physical state with examples, and then come to that calorific value. In general, calorific value means CV, calorific value, definition of calorific value, then classification of calorific values, gross and net calorific value, GCV and NCV or HCV and LCV. This is the equation to calculate net calorific value. That's about